Hi dear students, let's get started with the 9th grade chapter by name Matter in Our Surroundings. Now in this chapter, we are going to learn more and more about this word which is nothing but matter. Now if I ask the question to you all, what is matter? You all are quite familiar with that matter is something which occupies space plus it has mass. For example, if I talk about this marker, when I weigh it, it will have its own mass. And when I keep it on some other, table or a bench or something like that, it will occupy some place over there. Okay. So we can say that it occupies mass, or I can say that it has a volume, right? And then it has mass. What is the meaning of mass? We basically confuse ourselves telling that mass is equals to weight. There's a slight difference between mass versus the weight. Mass is nothing but how much of matter is there in a substance. It is, you can say that it is the exact weight of the object which doesn't change. We know that gravity changes on Moon, on Jupiter and all the other different planets. So as in how the gravity changes, our weight will also keep changing. Right? So weight changes depending on the gravitational influence. So where there will be gravity, if the gravity will be more, the weight will be more. If the gravity will be less, the weight will be less. But that doesn't happen with the mass. Because it is the actual weight of the object, it doesn't change anywhere. For example, if I take myself, on Moon, because the gravity is less, my weight might be less on Moon. Here on Earth, I have certain amount of weight. And when I go to Jupiter, my weight will increase automatically. But my mass will remain same on Moon, on Earth and on any other planet for that matter. So that is the difference. Mass is basically the exact amount of matter present in a substance, and weight is mass plus the gravitational influence on of the object, and that's the reason why mass remains same on all the places, in all the places, and the weight keeps changing depending on the gravitational force present in that particular area. Now we understood about the matter. That is nothing, it is anything which has mass and it occupies space. Now basically this matter can be classified based on either its chemical properties or its physical properties. In our chapter, we are going to focus more on these physical properties, and chemical properties we shall see in the other chapters of 9th standard. So if I talk about the physical properties, there are two schools of thoughts. The first school says that if I talk about a matter, it is continuous, as how I have this marker in my hand. It is continuous, okay? There is no gap between the matter. That is what one of the school of thought says. That means, that is, the matter is continuous. That is what one of the school of thought says. But the other school of thought says that matter is made up of particles. Now we know that science is a subject where we can't simply say something and leave it. We have to prove it, right? Now let's prove the points whether the matter is continuous in its nature or is matter made up of particles. Let's take an anecdote and try understanding it. We know that we dissolve sugar in water. We know that we dissolve salt in water. We know that once we keep, stirring it, the sugar and the salt completely dissolves in it. What does it say? Does it say that matter is continuous or matter is made up of particles? If we say matter is continuous, then there will be no dissolution, right? Sugar will not dissolve. Salt will not dissolve if it is continuous in its nature, but it is dissolving because it is made up of smaller particles, and once you keep hindering it, the particles will move apart, and you see that the particles will completely get dissolved in another matter. Here water is also matter, sugar and salt is also matter. So one matter dissolves in another matter because it is made up of particles. So that is the proof of it. So matter is not continuous in its nature, rather matter is made up of particles. After knowing the fact that matter is made up of particles, now let us talk about the states of matter. If I ask you all what are the three states of matter, it will be at the tip of your tongue. You might say that, ma'am, it is solid, it is liquid, and it is gas. So basically, all the matter that we see around ourselves are basically present in these three states. First one is solid, then we have liquids, and then we have gases. Now let us talk about their different properties and see the difference between them. Okay, if I talk about the first property, it is the shape. Right. Now let us try understanding about them in this through these particular diagrams. Think that this is a container which is full of solid, and this is a container which is full of liquids, and the last one is full of gas or gases, I can say. Now if I talk about the shape of any solid, again let's take the example of this marker only. I know that through the first point I have proved that any matter is it is made up of particles, right? That means even this pen which is there in my hand, a marker which is there in my hand, it is also made up of particles. But these particles are present in such a way that this marker has got a fixed shape, right? I cannot change it easily. That means I can say that this marker which is a solid, it has a fixed shape. So any solid if you take, it will have a fixed shape of its own. But liquid doesn't have the fixed shape. Rather, if you talk about the water, it will not have any fixed shape of its own. In whichever the container you pour the water, water will take the shape of the container. That means they always occupy the shape of container. Any liquid that you put in, it will occupy the shape of container, as well as the gases also, because gases also doesn't have any shape of their own. So even gases will acquire the shape of containers. So when we talk about this shape as a property, we see that solids have the fixed shape, liquids have shape of container, they acquire the shape of container, as well as the gases will acquire the shape of container. Talking about the volume. Okay, so when I talk about the volume, solids also will have a fixed volume. Okay, liquids will also have a fixed volume. I can say that this much of solid, if I want to put it in some box, this big the box should be, or this small the bag should be. For a liquid also I can say that whenever I want to fill in this liquid into a container, may it be a bottle, may it be any plastic cover, or may it be anything, that container should have capacity. That's the reason why we say that this is a bottle of half liter. More than half liter of water will not be able to fill in that. I say that this is the bottle of 2 liters. More than 2 liters will not be able to fill in that bottle. That means the volume of the liquid will be again fixed. But when it comes for the gases, we cannot say how much of the gas can be filled in which container, because increasing or decreasing the temperature, we can either make the gas expand or vice versa. That's the reason why the volume of the gas is not fixed. So this is the second property wherein the volume of the solid is fixed, volume of liquid is also fixed, but the volume of the gas is not fixed, rather it keeps changing depending on the temperature. Next one. How about the arrangement of the molecules or the arrangement of particles? Now we know that matter is made up of particles. So how are these particles arranged? If I talk about solids, remember we had taken these containers to understand the properties of the different states of matter. So if I talk about solids, The solids basically have the particles like these, wherein they are very close to each other. So we can say that the molecules or the particles of matter are compactly packed. Right? So the arrangement of particles in case of solids will be very compactly packed. The particles will be compactly packed. But if I talk about the shape of the liquid, I had spoken that shape of the liquid, there is no concept like that. Rather, the liquid acquires the shape of the container. That all happens because the molecules which are there, of course, they are there as a bunch. They are arranged. But there is no proper arrangement of those molecules. Some might be here and some might be there, and as a result, the molecules which are there, they are not tightly packed. Okay, so the molecules, they can move around. Okay, the molecules can move around. But when I talk about the gases, the molecules are really apart from each other. The molecules are apart from each other. So when I talk about the arrangement of particles, in the solids the particles are compactly packed. In the liquids, they move around. They are loosely packed and they move around. And in case of gases, the particles are present apart from each other and they can move randomly. Now, when I talk about the arrangement of the particles, the next question arises as, are those particles moving in any state of matter or they are stationary? They are standing in one place. Let us talk about that property, that is moment of particles. Or moment of particles or moment of molecules. When we talk about moment of particles or moment of molecules, children, see, if we want to move ourselves, we want some stimuli, right? Whether someone calls us, someone come and push us, someone come and pull us, all these things are the stimuli which makes us react, which makes us move. The same way, whenever the external energy is applied on the physical state of matter, any physical state over here, the particles will try to move. But just because in case of solids, the particles are compactly packed, they don't find much space to move around. And as a result, if we apply the external force or external energy, they will try to vibrate being in their own places. Okay, so they just vibrate in their places. But in case of liquids, whenever an external force or external energy is applied, we see that the particles of liquid will slide over each other. They will slide over each other. But in case of gases, the molecules will move apart. That is the reason why whenever an incense stick, what we call it as agarbatti, if it is kept in one corner of the house, the smell of that incense stick can be smelled across the house in all the rooms. Now that is happening because the incense stick molecules which are there, those aromatic molecules which are there, those particles are there in the gaseous form in the air. So they can easily move apart from each other, and as a result they spread across the whole house, and that's the reason why we'll be able to smell them. So that is all about the particles movement. Now coming to the next one, that is nothing but compressibility. Talking about the compressibility, any solid if you take, for example, this marker and a paper or a pencil or a metallic substance, okay, there is some limit to which you can compress. Even paper, you cannot compress it up to an extent that it is completely made into a very small mass. That is not at all possible, right? So solids can be compressed, but their compressibility is limited. So they can be compressed up to certain extent only, or we can say that they are not at all compressible. For example, if I talk about metals, they are not at all compressible. I cannot compress them. So they are non-compressible. But if I talk about liquids, I can compress them up to a certain extent. If I talk about the gases, they are more compressible. They are compressible in their nature. Let me give you an example. If I take 3 syringes, in one syringe I will take a solid like a paper or a metallic object or a chalk piece. In the other syringe, if I take water, and the third syringe, if I leave it just like that, I know that it will get filled with the air. Now if I try pressing, it will be easy for me to press the gas. The reason is, the gas molecules are apart from each other, okay, and that's the reason why they are very much compressible. But I can compress the liquid also, but I have to apply a little more force when compared to gas, because the liquids are compressible but they are less compressible. But when it comes for compressing the chalk piece inside the syringe, it will become really difficult because solids are non-compressible. If I have to compress them also, I have to apply a lot of force, then the solid material can be compressed. So these are the different properties of the matters, and through which we try to differentiate between the solids, liquids and gases. I hope everything is clear till here. Let's see you in the next video.